So this video is going to be about hybridization, and so we're going to start with the hybridization of methane, which is 1 carbon and then 4 hydrogens. So we're going to start with the just plain orbital structure of carbon. So carbon has 4 valence electrons. So there's first the non-valence electrons, the inner electrons, and then there's the 2s, and then there are 2p electrons. So I'm going to start by drawing it. So you have carbon here, which has 1, 2, 3, 4 electrons that are valence electrons. So when you add hydrogen, when you add 4 of them, you add 4 more electrons. So then you have, and each of these is a little hydrogen attached to it. Oops. So you have this, and then you have all of these. And each of the hydrogens are circling their own things. So the first step is making sure that, this has, like currently it looks like it only has 2 valence electrons. But since it has 4, something has to change here, and the orbitals have to hybridize. So one way to do that is you just get rid of one of the electrons in that orbital, and you bring it out to here. But when that happens, they're not they don't have the same energy. This one has higher energy, and that one has lower, but they all need to be the same. So what happens is they all hybridize. So then you are left with 4 in the sp3, because there are 3 p orbitals here and 1 s orbital, and they all hybridize to form a shape that, so the p orbital looks like that, and the s orbital looks like this. So what happens is they hybridize and form a new shape which looks like that, which is 75% p orbital and then 25% s orbital. So now we have carbon, and its orbital, or its electrons, have been hybridized. So now, and I'm not going to draw all of the little small bits there, it's just going to get in the way, but we're going to have carbon, which is going to have 1, 2, 3, 4. And this is in the tetrahedral shape, which is like the 3-dimensional, that thing there. Now in each of these, there's 1 electron. And you can have 2 electrons in each orbital. So hydrogen, which has an orbital shell, as we determined here, like this, has 1 electron in it. So what happens is just kind of attaches to it like this. And each of these is a hydrogen, and so that's the hybridization of methane, which is 1 carbon with its 4 valence electrons and 4 hydrogens, each with 1 valence electron. Alright, so now we're going to work with the ethylene molecule, which is 2 carbons and 4 hydrogens, and each carbon is bonded with 3 other atoms. Now I've already drawn the valence electrons for it, so we have 1 2s and then 3 2p. And so for this time, since there's only 3 other atoms it's bonded to, we're only going, instead of needing 3 p shells, we're only going to need 2. So instead of sp3, we're going to have sp2, because we only need to borrow 2 of the p orbitals. So then we're going to be left with sp sp2, and we're going to have doop, doop, and above it is going to be 1p orbital. So now this shape looks the exact same, or almost the exact same, as the sp3, but instead of but relative to itself, it's going to have a slightly larger small part and a slightly smaller big part of the dumbbell shape than of the so this would be like the sp3, and this is the sp2. And since there are only 3 total orbitals, there's going to be 33% s orbital shape in there, and then 67% p orbital shape. So I'm going to need more space for this one. So I'm going to draw the actual bond between them. So there are the 3 sp2 orbitals, and just one right here. And since they look like the little small part that's just kind of hanging out in the center there, we don't need to draw that. And then we do the same thing over here. Oops. And then we are also going to use a different color for this one. Going to draw the single p orbital, which with its dumbbell shape comes out on both ends. Now with this, we're going to have 1 electron in each orbital here. And these ones are going to come together in a sigma bond, which looks something like that or something. And same with all these and their hydrogen pairs. H, H, H. All right, and all of these are sigma bonds because they're just like, oops, they're direct bonds with each, they're head on essentially. These ones here, however, they're parallel to each other. So what they're going to form is going to be a pi bond. And this whole area here is going to be bonded, and so is this whole area. And so that kind of keeps them so they can't just rotate all over the place because there's a double bond between the 2 carbons, and then the hydrogens are on their other places. Alright, so just a quick overview of the sp orbital. This is essentially the same thing, except that it is the 2 parts of the dumbbell are more similarly shaped. So in an sp, they look something like that. In an sp2, look something more like that, with a larger shape here. And then an sp3, it looks something like that, with a much smaller and much larger piece there. Now, each of these also have different percentages of each hybridization, of each orbital that's in the hybridization. So this one, since there's only one s and one p, it's going to have 50% and 50%, because it's 1 and 1. In the sp2, it's going to have 3, so it's going to be 33% sp or s, and then 67% p because there's 2. And then in the sp3, it's going to be 25% s because there are 4 total, and there's only 1 s, and then 75% p because there are 3 in comparison to the 4 total.